Welcome back everyone, and today we're going to jump in and do an introductory lesson on finite element analysis. So far we've been talking about stress analysis, forces, and how materials react to those forces, and we're going to use this analysis system, which is awesome. Fusion does a great job with this, and you're going to look at your design, the material, and it's going to tell you what kind of stresses. It'll show you, does it surpass your yield strength? Does it surpass your ultimate strength in this design and material? So really cool. I want you all to follow along and draw the same exact thing out with me today. Very simple. We're going to do create sketch. I want to just create it on the XY plane. I'll just put me a rectangle in here and something real simple. It's going to be 5 millimeters by 18 millimeters. And then finish it out. And then I want to extrude this thing. We'll extrude it out maybe 100 millimeters. Alright, so we got this little bar here, and we're going to make it like a cantilever system. We're going to have it locked in over here like it's welded, and I want to put a pressure over here and see what kind of, we'll put a force of like 100 newtons on it, and let's see how this material reacts to the pressure or the force of it. So let's jump in here. Before we get too far along, we've got the design, we've got to add a material. And I want to go ahead and save this one. So I hit save, and this will be an example beam, which would be good. So now you see example beam there. I want to right click on this, and I want to come down to physical material. Like I said, it's not going to do any good to do an analysis on something if you don't know what the material is, because that's the main thing. When I open this up, you see the physical material here. It is steel when I hover over it. Now you've got anything you could imagine over here to make the material out of. We're going to use plastics because that's what we're working in, and they have ABS, acrylic, nylon, anything you can think of. So I'm just going to grab ABS for right now and come up here, and all you have to do is just let me pull this up a little bit. Just come up here and just go right over top of that steel, and you see how it changes it. Just to make sure, you can right click on this up here at the top, oh, I gotta hit close on this. Come down here and close. I can right click on example beam here and go to properties, and it'll show me what is my material made out of, and it is ABS plastic, exactly what I want to know. So I close that out, and now let's go in and let's do the analysis on it. And right now when you're designing, everything we've done has been in design, so now you want to come down to simulation. And you see the little image they have here. You see the blues, the light blue, the green, the yellow, and the red. This is going to show you where the major stresses are inside of the part whenever a load is applied. So I hit simulation, and the new study, it's going to have a new study every time you're in here, and there's all kinds of different ones depending on what you're doing, but we are doing static stress. Okay, and inside of this static stress, I am going to turn it like this and kind of turn it like that. And the first thing that I really need to do is to lock this side, because like I said, this is going to be a cantilever system. This is going to be like welded to a column, like a post. All right, and the pressure is going to be applied to this end, and let's see what happens. So I want to hit constraint. This is how that you constrain this side like you're welding it, and I want to do structural constraint and fixed. Yeah, so my target would be this. I'm not picking on lines, I'm picking on the surface. Y'all see that? And I hit OK. So now this is locked. So when I put pressure on this, the whole thing doesn't go down. It's actually, this is going to be constrained and locked. So I'm pushing on this, and you're going to see the stress that's going to build up inside of this when that force is applied. So now we have that set up. So let's turn it like this. Now I'll go to loads, structural loads. And what I want to do is I want to put it right there. And I want the force not at an angle, I want it to come straight down on this in a Y direction. So, and again, it just depends on how you draw this up where your Y is. I want to put 100 pounds on this, okay? But you'll notice my force is going up. Well, that's not going to do any good. It has to be coming down on it. So I have to go minus. And it's not going to mess up any numbers or anything. This is just the direction of the force, and it's coming down. But if for some reason yours is like, if you chose Y and your X and Y, it just depends on how you draw it. If it's coming from the side, just find, you might have to go 0 on this and find, like this one's coming from the side. You might have that on your Y because of the way you drawed it. Just find it. It'll be one of them, and catch that just like I did. So hit OK on that. So now you have the material already selected. We done ABS plastic, right? You've got the constraint, and now you've got a force applied. So we want to do a pre-check. You can do a pre-check. Before we do that, I want to go to materials. I want to show you something. Material properties. And this is our material properties here. And it's got our yield strength, our ultimate strength is in here. So what I want to do now, after I have that in there, and it did say ABS material. This is all this. So at this point, I'm going to go in and start a pre-check just to make sure. This study has all the information required, so we have everything that we need. So I hit OK on that, and now I am going to let's go in and let's see what's going on with it. So I want to hit solve. Did y'all see that? So I hit solve on it, and everything's ready. Solve one study, and it's going to go through, and you all see it's starting the process, and it's going to take, it's about 30% completed. It takes a little bit of time to do this. All right, we are, the results are up, and it shows actual minimum safety factor. Oh, this don't look good. Anytime you've got a red exclamation point, that's not good. The design is expected to bend permanently or break under the current analysis criteria. So, right? So, I'll close this and check this out. All right, this is the stress that's going on inside of this beam, okay? Now, this would have been, we could have actually made the mesh on this. We could have made the mesh a little bit finer, we could have done that, and it actually had a little bit better, it would have probably showed up a little bit better, and we will do that a little bit later on, but for this one it's fine. But notice here, you've got the greens. This means it's good. Back there we're good, and you'll notice it follows pretty much the center of this beam. But now we're, and pretty much everything looks really good. Not bad. I mean, we're getting yellows in here, but the problem of it is, you see the red. This right here, this area is under tension, and this area is under compression down here. So this would be the area that this thing would probably break, would be right in this little V. You all kind of see that? So this is really good. Now let's go in there and look at some more results on this. If you hit animate on this, you can actually hit play and watch this thing as the pressure is applied. Alright, you can actually record this, and that's what I want you guys to do, is record this for me. Record, and that would be great. And put on your put it somewhere where you can find it. I put mine on my desktop, and this one would be my beam analysis. Okay, and save that. Now you'll have that video, and also you see how it's going through and just showing us. Oh, and here is the actual video that I just made. So that is awesome. So we come back to this, and I want to see now, I want to see my report. So I want to do a preview of this report, and this shows you everything that's going on throughout this this component that we applied the force to. And again, this is ABS plastic. We have a yield strength of 20 megapascals. Ultimate strength is 29.6 megapascals. So that is our yield strength and our ultimate strength. And as we come down through here, it shows you all kinds of information. And the displacement is really huge here. This is how much deflection we had. Overall, we had 6.198 millimeters. All right, that's how much it deflected. So, and you're seeing most of it was in the Y direction. You'll see a little there, got a little bit in the X, a little bit in the Z, but Y is mostly where the deflection happened at. And of course, that's opposite, to the force that we put on it. It was reacting to that force and trying to push back. But 6.198 millimeters. Our overall thickness of that part was 18 millimeters. So, that's 1/3 of its width there is how much it deflected. So ultimately this would have broke, and there's no doubt about that. But again, did you guys see how important this is? And this could help you in designing in the future, is to understand that right here's what it looks like. Right here is the danger zones. So we could add more material at these places to strengthen that. And even in these green sections, we could eliminate some of that material. We can make voids in that and grooves. And remember, as we use the spline tool in here, we could use that because it's green. Very little pressure is being placed on that. Right here is our main concern. Okay? So what I want you guys to do is, of course, I want you to do the same project that I did, and I want you to take on your results here, I want you to take a screenshot of it, and I want your video, and I want you to send that to me, guys. And if you all have any questions about that, this project and FEA analysis, just let me know.